KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Good morning, students. But the next concept in trigonometry is the trigonometric equations. We are discussing trigonometry chapter. Okay. Next concept in trigonometry is trigonometric equations. Okay. Now we know polynomial equations. Now something like this, if you write some x square minus 5x plus 6 equal to 0, it is a polynomial equation. Now similarly, what is a trigonometric equations? Equations involving trigonometric functions of a variable. Okay, if you write something like this, sin square x minus 3 sin x plus 2 equal to 0. It is a trigonometric equation. Okay, equations involving trigonometric functions of a variable are called trigonometric equations. Okay, now something like if you write cos square x minus cos x plus 1 equal to 0. Okay, tan square x minus 2 tan x plus 7 equal to 0. Something. Okay, equations involving trigonometric functions of a variable are called trigonometric equations. Okay, like we write polynomial equations. Okay, similarly we will write trigonometric equations. Okay, equations involving trigonometric functions of a variable are called trigonometric equations. Okay, now what we know? Already we know that sin x, cos x repeat after an interval of 2 pi. After an interval of 2 pi. All trigonometric functions are called circular functions. Circular functions. Okay, after certain interval the values repeat. Now for example, if I write sin x is equal to 1 by root 2. Sin x equal to 1 by root 2 means x is equal to what? Pi by 4. Or x is equal to pi minus pi by 4. Okay, or else x is equal to 2 pi plus pi by 4 also. Means after an interval of 2 pi values repeat for sin x and cos x. Okay, sin x and cos x values repeat after an interval of 2 pi. Okay, whereas tan x values repeat after an interval of pi. After an interval of pi. Okay, now sin x and cos x values repeat after an interval of 2 pi, whereas tan x values repeat after an interval of pi. Okay, if I write tan x is equal to 1. Tan x is equal to 1 means x is equal to pi by 4. X equal to pi by 4. So x equal to pi by 4, tan x equal to 1 means x equal to pi by 4, or else tan x equal to 1 means tan of pi plus pi by 4 is also 1 only, no? So value repeated after again an interval of pi. Okay, or else tan of 2 pi plus pi by 4 is also 1. Tan of 3 pi plus pi by 4 is value is also 1. Okay, so values repeat for tan x, values repeat after an interval of pi. Okay, sin x and cos x, these values for these trigonometric functions, values repeat after an interval of 2 pi, whereas tan x values repeat after an interval of pi. Okay, next, solutions of a trigonometric equation. Solutions of trigonometric equation for which x lying between 0 to 2 pi. Closed interval 0 to open interval 2 pi, x lying between closed interval 0 to open interval 2 pi are called principal solutions. Are called principal solutions. Okay, solutions of a trigonometric equation for which x lies between closed interval 0 to open interval 2 pi are called principal solution. Okay, now for example, sin x is equal to 1 by root 2. Sin x is equal to 1 by root 2. What are the solutions we can give? X is equal to pi by 4 is one solution. X is equal to 2 pi, pi minus pi by 4 is one solution. X is equal to 2 pi plus pi by 4 is one solution. X is equal to 3 pi minus pi by 4 is one solution. Like this we can give many solutions. Can give many solutions. Among those, values of x which lying between 0 to 2 pi. Okay. Solutions of trigonometric equations for which 0 less than or equal to x less than 2 pi are called principal solution. Okay. X belongs to closed interval 0 to open interval 2 pi are called principal solution. Okay. Next, beyond 2 pi, these are called general solution. Okay. Expression involving integer n which gives all solutions of trigonometric equation is called general solution. Okay. Now if you start writing sin x is equal to 1 by root 2, we can give infinite many values of x. You can get infinite many values for x because sin x is equal to 1 by root 2 means x is equal to pi by 4, x is equal to pi minus pi by 4, x is equal to 2 pi plus pi by 4. Like that we can write infinite values for x. Okay. Now for those infinite values we will give some expression. Okay. That expression involving n gives all solutions of a trigonometric equation is called general solution. Okay, and there are two types of solutions. One is the principal solution, one is general solution. Okay, principal solution means you have to give value of x in the interval 0 to 2 pi. Okay, general solution means you have to give general form. Okay, you have to give general expression which gives all solutions of the trigonometric equation. Okay. Now, first of all, trigonometric equation means an equation involving trigonometric functions of variable are called trigonometric equations. Okay. Now, sin x, cos x repeats after after an interval of 2 pi and tan x repeat after an interval of pi. Okay. Solution of a trigonometric equation lying between closed interval 0 to 2 pi are called principal solution. Okay. An expression involving integer n which gives all solutions of trigonometric equation is called general solution. Okay, what is trigonometric equation? What is interval of sin x and cos x? Sin x and cos x repeat after an interval of 2 pi. Okay, periodicity you can call it as sin x and cos x. Periodicity is 2 pi. Okay, tan x periodicity is pi. Okay, principal solution means a solution which gives in the interval 0 to 2 pi. Okay, general solution means expression which gives all the solutions of trigonometric equation. That is general solution. Okay. Now we will discuss some example problems. First one, find the principal solutions of equation sin x is equal to root 3 by 2. Find principal solutions of the equation sin x is equal to root 3 by 2. Okay, sin x is equal to root 3 by 2, principal solution. Principal solution means we have to give values of x in the interval, closed interval 0 to open interval 2 pi, satisfying the condition sin x is equal to root 3 by 2. Now what we know? In first interval all trigonometric ratios positive, no? So sin x positive means x value lies either in first quadrant or in second quadrant. Okay. Here what it is a trigonometric equation here, sin x is equal to root 3 by 2. Okay, sin x is equal to root 3 by 2. Sin x positive means x lies either in first interval or second interval. Okay, first quadrant or second quadrant. Okay, sin x is equal to root 3 by 2. Sin x positive means x lies either in first quadrant or in second quadrant. In first quadrant, what we know? Sin 0, 0, sin pi by 6 is 1 by 2, sin pi by 4 is 1 by root 2, sin pi by 3 is root 3 by 2. So, sin pi by 3 value is how much? Root 3 by 2, no? Okay, what we know? Sin pi by 3 is equal to root 3 by 2. So, x equal to pi by 3 is one of the solution. X equal to pi by 3 is one of the solution of sin x is equal to root 3 by 2. Okay, but this is one of the solution, but it is not the only solution. We have one more solution because sin x is equal to root 3 by 2. Sin is positive in first and second quadrant. So, we will give one more angle in second quadrant also. So, sin 2 pi by 3. What is sin 2 pi by 3? Sin 2 pi by 3 what we can write? Sin pi minus pi by 3. Sin 2 pi by 3 we can write as pi minus pi by 3. Sin pi minus theta is sin theta. So sin pi minus pi by 3 is sin pi by 3. Sin pi by 3 value is how much? Root 3 by 2. Means sin 2 pi by 3 value how much we got? Root 3 by 2. Sin 2 pi by 3 value is root 3 by 2. So one more value of x satisfying the condition, that is sin x equal to root 3 by 2, means x is equal to 2 pi by 3. So what are the solutions we got? X is equal to pi by 3 and x is equal to 2 pi by 3. X is equal to pi by 3 and x is equal to 2 pi by 3. Okay. So sin x is equal to root 3 by 2. Sin x positive means x lies in first quadrant and second quadrant. First quadrant value satisfying sin x equal to root 3 by 2 is pi by 3. Second quadrant angle is pi minus pi by 3. Pi minus pi by 3 is 2 pi by 3. Okay. So sin pi by 3 is equal to root 3 by 2, sin 2 pi by 3 is equal to root 3 by 2. So values of x satisfying sin x equal to root 3 by 2 are x is equal to pi by 3 and x is equal to 2 pi by 3. Okay, these are two principal solutions. Okay. Next, find principal solutions of the equation tan x is equal to minus 1 by root 3. Tan x is equal to minus 1 by root 3. Okay, principal solutions of the equation tan x is equal to minus 1 by root 3. But tan x is equal to minus 1 by root 3. Tan x negative, right hand side negative, tan x negative, tan negative in second and fourth quadrant. And tan is positive in first and third quadrant, tan is negative in second and fourth quadrant. Okay, so tan x negative means here x lies in second quadrant and fourth quadrant. We have to give principal solution, means we have to give in 0 to 2 pi. In the interval 0 to 2 pi, 0 to pi by 2 first quadrant. In first quadrant tan positive, so x does not belongs in lies in first quadrant. Okay, second quadrant tan negative. Okay, so x belongs to second quadrant, means x belongs to somewhere in pi by 2 to pi. Okay, tan x positive in third quadrant, so x does not belongs in third quadrant. X belongs to fourth quadrant because x is negative in fourth quadrant. So two values of x will get, one in second quadrant, one in fourth quadrant. Okay, now tan x equal to minus 1 by root 3. Now tan x equal to 1 by root 3, for example, tan x equal to 1 by root 3 means x is equal to pi by 6, tan pi by 6 value is 1 by root 3. Okay, so what we know, tan pi by 6 value 1 by root 3. So negative second quadrant means what we can write, pi minus theta. So what we can write, tan pi minus pi by 6. Tan pi minus theta is minus tan theta. So tan pi minus pi by 6 equal to minus tan pi by 6. Okay, tan pi by 6 value 1 by root 3 multiplied by minus is minus 1 by root 3. Okay, pi minus pi by 6. Pi minus pi by 6 is what? 5 pi by 6. So tan 5 pi by 6 is equal to minus 1 by root 3. So tan 5 pi by 6 equal to minus 1 by root 3. So 5 pi by 6 is one of the principal solution of tan x is equal to minus 1 by root 3. But this is not the only solution, because tan is negative in fourth quadrant also. Okay, so second quadrant angle, how we wrote, tan pi minus theta. So fourth quadrant angle, tan 2 pi minus theta. Okay, so again tan 2 pi minus pi by 6, tan 2 pi minus pi by 6. But tan 2 pi minus theta, what we know, tan pi minus theta or pi plus theta, 2 pi minus theta or 2 pi plus theta will get same trigonometric ratio. So tan 2 pi minus pi by 6 is tan pi by 6, but 2 pi minus is in fourth quadrant, in fourth quadrant tan negative, so minus tan pi by 6. So minus tan pi by 6 minus tan pi by 6 value 1 by root 3, so minus 1 by root 3. Okay. So tan 5 pi by 6 value is minus 1 by root 3, tan 11 pi by 6 value is minus 1 by root 3. Okay, tan 5 pi by 6 is equal to tan 11 pi by 6 is equal to minus 1 by root 3. So principal solutions are what? 5 pi by 6 and 11 pi by 6. Okay, second quadrant angle and fourth quadrant angle will get. Okay, so tan pi minus pi by 6 is one solution, tan 2 pi minus pi by 6 is one solution. Okay, tan pi by 6 value 1 by root 3. So minus 1 by root 3 means second quadrant angle and fourth quadrant angle. So second quadrant angle, how we will write, tan of pi minus pi by 6, that is second quadrant angle, that is equal to minus 1 by root 3. Nothing but tan 5 by 6 is minus 1 by root 3. Okay, one angle, one value of x satisfying tan x equal to minus 1 by root 3 is 5 pi by 6. Similarly, fourth quadrant angle, that is the tan 2 pi minus pi by 6. Okay, tan 2 pi minus pi by 6 is what we can write, minus tan pi by 6. Okay, minus 1 by root 3. So tan 5 pi by 6 and tan 11 pi by 6 satisfies tan x equal to minus 1 by root 3. So x is equal to 5 pi by 6 and 11 pi by 6 are principal solutions. Okay, next. Here, see here, sin x equal to 0, cos x equal to 0 and tan x equal to 0. Okay, sin x equal to 0, cos x equal to 0, tan x equal to 0. Okay, for these we'll write general solutions now, general solutions. Now sin x equal to 0. Now sin is 0 whenever x is an integral multiple of pi. X is an integral multiple of pi. Okay, so sin 0 0, sin pi 0, sin 2 pi 0, sin 3 pi 0, sin 4 pi 0, sin minus pi 0, sin minus 2 pi 0, sin minus 3 pi 0. Okay, sin x equal to 0. What is it meaning? X is an integral multiple of pi. So sin x equal to 0 gives x is equal to n pi, where n is any integer. Okay, sin 0, sin x equal to 0 means x is an integral multiple of pi. Now general solution means what we can give? General solution means sin x equal to 0 means x 0, pi, 2 pi, 3 pi, 4 pi, 10 pi. So we can give infinite answers. So for that, instead of giving infinite answers, we will give general expression, that is x equal to n pi. If x equal to n pi and n is an integer, sin x is 0. Okay, next, cos x equal to 0. Cos x equal to 0, cos is 0 for odd multiples of pi by 2. For odd multiples of pi by 2. Okay, cos pi by 2 0, cos 3 pi by 2 0, cos 5 pi by 2 0, cos minus pi by 2 0. Okay, so cos x equal to 0 gives x is odd multiple of pi by 2. Okay, 2n plus 1 into pi by 2, where n is integer. Okay, 2n plus 1 odd multiple of pi by 2, where n is integer. Cos x equal to 0 means x is an odd multiple of pi by 2. X is an odd multiple of pi by 2. Okay, next. Now sin 0 means x is integral multiple of pi. Cos x equal to 0 means x is odd multiple of pi by 2. Okay, where n is integer. Here n is integer. Okay, next, tan x equal to 0 means there is no separate condition for tan x equal to 0, because the tan is ratio of sin upon cos. No? So whenever is sin is 0, tan is 0. So tan x equal to 0 gives condition of sin x, that is x is equal to n pi, where n is integer. Sin x equal to 0 means x is integral multiple of pi. Cos x equal to 0 means x is an odd multiple of pi by 2. Tan x equal to 0 means x is integral multiple of pi. Okay, but these are the conditions for 0. Okay, sin 0, cos 0 and tan 0. Okay, sin x equal to 0, cos x equal to 0 and tan x equal to 0. Okay, sin x equal to 0 means x is equal to integral multiple of pi. Okay, cos x equal to 0 means x is odd multiple of pi by 2. Tan x equal to 0 means x is an integral multiple of pi. Okay, now first theorem, theorem 1, for any real number x and y, for any real numbers x and y, if sin x equal to sin y, if sin x equal to sin y, that implies x is equal to n pi plus minus 1 whole power n into y. Sin x equal to sin y means x is n pi plus minus 1 whole power n into y, where n is integer. Okay, now if sin x equal to sin y, if I write sin y this side, but this is the general solution. Sin x equal to sin y means x is equal to n pi plus minus 1 whole power n into y, where n is integer. Okay, now if sin x equal to sin y, now if I write sin y this side, what we get? Sin x minus sin y equal to 0. Okay, so sin x minus sin y equal to 0. Now sin x minus sin y formula, 2 cos x plus y by 2 into sin x minus y by 2. Okay, 2 cos x plus y by 2 into sin x minus y by 2 equal to 0. Okay, but this product 0, here 2 is non-zero, means this is 0 or this is 0. No? Okay, so cos x plus y by 2 equal to 0 or sin x minus y by 2 equal to 0. Okay, cos x plus y by 2 equal to 0 or sin x minus y by 2 equal to 0. Okay, now if cos, suppose if you consider this as theta. If cos theta equal to 0, theta is equal to what? Odd multiple of pi by 2. Okay, so x plus y by 2 is 2n plus 1 into pi by 2, no? Cos of x plus y by 2 equal to 0 means x plus y by 2 is odd multiple of pi by 2. That is x plus y by 2 is equal to 2n plus 1 into pi by 2. Okay, both sides 2 cancel and write y this side. So what we get? X is equal to 2n plus 1 into pi minus y. Okay, odd multiple of pi minus y. Okay, so x is equal to odd multiple of pi minus y. This is one condition. Okay, next sin x minus y by 2 equal to 0. Okay, sin x minus y by 2 equal to 0. Sin theta equal to 0 means theta is integral multiple of pi. So x minus y by 2 is equal to n pi, where n is integer. So x minus y is equal to what? 2n pi. So x is equal to what we will get? 2n pi plus y. But two conditions we got. X is equal to odd multiple of pi minus y, or x is equal to even multiple of pi plus y. X is equal to odd multiple of pi minus y, or x is equal to even multiple of pi plus y. Here we have two conditions. One is x is equal to odd multiple of pi minus y, or x is equal to even multiple of pi plus y. Okay, now combined condition of these two, what we can write is x is equal to n pi plus minus 1 whole power n into y, where n is integer. Okay, x is equal to n pi plus minus 1 whole power n into y, where n is integer. Now what we have two conditions? X is odd multiple of pi minus y, and x is even multiple of pi plus y. Now for example, if you consider n value 1, so what we get? Pi minus y, like this, odd multiple of pi minus y. Suppose n value 2 pi plus y, something like this. So combined condition of these two, what we can write? X is equal to n pi plus minus 1 whole power n into y. Okay, so sin x equal to sin y implies x is equal to n pi plus minus 1 whole power n into y, where n is integer. Okay, writing this term this side. Okay, sin x minus sin y formula, 2 cos x plus y by 2 into sin x minus y by 2. Okay, product 0 means either this one 0 or this one 0. Cos x plus y by 2 0 means x plus y by 2 is odd multiple of pi by 2. So x plus y is equal to 2n plus 1 into pi. So x is equal to 2n plus 1 into pi minus y. Okay, now sin x minus y by 2 equal to 0 means x minus y by 2 is integral multiple of pi. X is equal to 2n pi plus y. So combined condition of these two is x is equal to n pi plus minus 1 whole power n into y, where n is integer. Okay, the next theorem 2, for any real number x and y, if cos x equal to cos y, that implies x is equal to 2n pi plus or minus y. X is equal to 2n pi plus or minus y, where n is integer. Okay, for any real numbers x and y, if cos x is equal to cos y, means x is equal to 2n pi plus or minus y, 2n pi plus or minus y, where n is integer. Okay, now if cos x equal to cos y, and write cos y this side, what we have? Cos x minus cos y equal to 0. Okay, cos x minus cos y equal to 0 means cos x minus cos y formula is what? Minus 2 sin x plus y by 2 into sin x minus y by 2. Right hand side equal to 0. Okay, cos x minus cos y formula, 2 cos x minus cos y formula minus 2 into sin x plus y by 2 into sin x minus y by 2. Okay, right hand side equal to 0. So product 0 means either this term 0 or this term 0. So what we have? Either sin x plus y by 2 equal to 0 or sin x minus y by 2 equal to 0. Okay, either sin x plus y by 2 equal to 0 or sin x minus y by 2 equal to 0. Okay. Now sin 0 means this has to be a multiple of n pi. So x plus y by 2 equal to n pi. So x plus y by 2 equal to n pi means x plus y is equal to 2n pi. So x is equal to what? 2n pi minus y. X is equal to 2n pi minus y. That is one condition. Okay, we have one more condition, that is sin x minus y by 2 equal to 0 means x minus y by 2 is equal to what? N pi. X minus y by 2 is equal to n pi. So x minus y is equal to what? 2n pi. So x is equal to 2n pi plus y. Here what we have? X is equal to 2n pi minus y. Here what we have? X is equal to 2n pi plus y. Okay. Now combining these two results. So what we get? X is equal to 2n pi minus y or x is equal to 2n plus y. So what we can write? X is equal to 2n plus or minus y. 2n pi plus or minus y. Okay. If you consider plus here, you get this one. If you take minus here, you get this part. Okay. Next theorem. Prove that if x and y are not an odd multiples of pi by 2. Now here x and y are not odd multiples of pi by 2. X is not an odd multiple of pi by 2 and y is also not an odd multiple of pi by 2. Then if tan x equal to tan y, that implies x is equal to n pi plus y. X is equal to n pi plus y, where n is integer. If tan x equal to tan y, then general solution is what? X is equal to n pi plus y. Okay. Now tan x equal to tan y. Tan x equal to tan y, if you write tan y this side, so what we get? Tan x minus tan y equal to 0. Tan x minus tan y equal to 0. Now what is tan x? Sin x upon cos x minus tan y sin y upon cos y equal to 0. Now if you take LCM, product no, denominator is cos x into cos y comes to this side and cos x comes to this side. So numerator is sin x cos y minus cos x sin y upon denominator is cos x into cos y. Right hand side equal to 0. Okay. Ratio 0 means numerator has to be 0, no? Numerator has to be 0. Anyhow denominator is non-zero because x is not an odd multiple of pi by 2. So cos x is non-zero. Okay. Y is also not an odd multiple of pi by 2. So cos y is also not 0. So cos x non-zero, cos y also non-zero. So denominator is non-zero. Numerator sin x cos y minus cos x sin y. Okay, sin x cos y minus cos x sin y. What we can write? Sin of x minus y. Okay, sin of x minus y upon cos x cos y equal to 0. So numerator has to be 0. Means sin x minus y equal to 0. Okay, sin x minus y equal to 0. Sin x minus y equal to 0 means x minus y is what? An integral multiple of pi. So x minus y is equal to n pi, where n is an integer. X minus y is equal to n pi, where n is an integer. Okay. So x minus y is equal to n pi means x is equal to what? N pi plus y. X is equal to n pi plus y, where n is integer. Okay. But these are three theorems, three important formulas for general solutions. If sin x equal to sin y, x is equal to n pi plus minus 1 whole power n into y, where n is integer. Okay, cos x is equal to cos y, then x is equal to 2n pi plus or minus y, where n is integer. Okay, tan x is equal to tan y, then x is equal to n pi plus y, where n is integer. Okay, my next class will discuss problems related to this concept. Okay, I will continue remaining problems in next class. Thank you.